Alright, so before we move on to the calculation, I know that you might wonder, so what is support and what is confident, and how are we going to relate that with real market basket analysis or association rule mining? So how is the real world example? So for example, you got the two item here, that is computer and also antivirus software. So we would like to see the correlation of these two, for example, or the frequent item set mining of these two. For example, if a person bought a computer, they will also bought the antivirus software. So support, we have a figure here that is 2%, and then confidence here we get 60%, for example. So what does it mean? It means that 2% of all transactions showed that computer and antivirus software are purchased together out of all of the item in the computer shop, right? So only 2% of computer and antivirus software being purchased together, while 60% of confidence, meaning that 60% of customer who purchased computer will also bought the antivirus software. So that is what it means by support and confidence here. Now, let us take a look at the frequent item set mining basic concept. So this is for frequent pattern and association rule as well, a priori. So what is item set? Item set is a set of one or more item, right? And D is the relevant data. Be a set of database transaction, and each transaction T is a set of items such that one transaction is a subset of item X, right? And then support means frequency of occurrence of an item set, and we say that item set is frequent if support is no less than a minimum support threshold. So this is where we are going to do the basic calculation or the basic step. Okay, so in the question you will be given the transaction ID and the item bought. So you have how many transactions here? 4 transactions, 1, 2, 3, 4. And then in the item as well, you are going to have another column here, that is the item bought, A, B, C, and the second transaction is A and C. And then also in the question you will be given the minimum support and the minimum confidence. Okay, to take a look at which rule is the most frequent and the most interesting. So from here, you are going to do 2 steps. Step 1 is to calculate the support value, and step 2 is to calculate the confidence value. So let's say in doing the support value, so what you have to do is you need to calculate the frequency of it over all transaction, right? So for example, you have here frequent pattern of A. You would like to see frequency of A. So what is the support of A? Okay, what is the frequency of A being bought? Okay, so you have you take a look at A here. So how many transactions that you have found? 1, 2, and 3. So it will be 3 over all transaction would be 4. So that is why you get 75. Same goes to B and C. What about D here? D would be 1. Okay, 1 over 4. So equal to 25%. And what about A and B here? What about A and B? How many times it occurs together? A, B, okay, once only. Okay, so meaning that it will be 1 over 4, 25%. What about A and C? A and C together, okay, and A and C together, 1 over 4. So you have, 2 over 4, so you got 50 here. What about A and D? A, D is just 1 over 4. If you take a look at here, something that is being struck here, right? Okay, there are three row has been struck. Why? Because it does not meet the minimum support that we are assuming. So this is the thing that we have been given, or we assume. Okay, usually in the question it will be given, right? So minimum support less than 50 will be discard. Okay, so meaning that D is being discarded, or D, we can say that D is not that frequent in our case. And then A and B, item A and B is not that frequent being bought together, so we don't have to analyze it. And also A and D is not that frequent, so we have to discard all of these three frequent pattern. Next, we have to calculate the confidence value. So how are we going to calculate the confidence value? So for example, we would like to see the confidence of when a person bought A, they will also bought C. So from here, we are going to use the, we will calculate support. Okay, we have calculated it in fact. And we need to calculate the confidence. So in confidence, we are going to divide support of what they call it, combination of A and C over support of A or support of the antecedent. So in this one, so the result of support A and C is, how much is it? 50, right? 50 or 2 over 4. Over PA is 3 over 4 here. So we got here 2 over 3, that is 66.6%. So the confidence is 66.6%. It is more than the minimum confidence. So we don't have to discard this. So this is actually the basic concept of doing the support and confidence value. But then we know that Apriori is a mining frequency item that it will generate or candidate, and it will do the brute force, right? So in Apriori, what you have to do, you got a few steps inside there, okay? So initially, you have to scan the database once to get the frequent one item set, right? And then this is what we have done previously, right? But I just want you to take a look at the real step here for Apriori. And then we are going to generate length K plus 1 candidate. So for example, before this, we have generated one item set. So we are going to generate two item set here. Two candidate item set from length K frequent item set. And then we will test the candidate against the database. And we will terminate when no frequent or candidate set can be generated now. So, any subset of frequent item set must be frequent. For example, if milk, diapers, nuts is frequent, so is milk and diapers. Okay, and then every transaction have milk, diapers, nut, meaning that it will also contains milk and diapers. We also need to do the a priori pruning principle, meaning that if there is any item set that is infrequent, so its superset should not be generated or tested. So we will take a look at it later on. Right. So this is the first step. Okay. So the first step is to do a brute force approach that traverses all possible item set, determine their support, discard the infrequent set is usually invisible here. So the numbers of possible item set will grow exponentially with the numbers of items. So typically, typical supermarkets often offer tens of thousands of different products. So it will be a large or a very massive calculation if you get the real world data set. So in a priori property, it has no superset of an infrequent item set that can be frequent, meaning that it is downward closure, breadth search, and you have to calculate the support value. So this is how, or the example of the a priori algorithm. So step 1, you have to self-join to find a set of candidate, and then the candidate is denoted as CK. And then next is you have to do the pruning, meaning that the candidate or the subset of candidate that is does not meet the support minimum need to be removed. So let us take a look one by one of it. Okay, so say in the database you have here, right, how many transactions? There are 4 transactions. You have ID 10, TID transaction ID 10, 20 and 30 and 40 here, and then you have those items. So what you have to do before that, you need to determine your support. So you have to check the support. So this is what we have been given, or we have assumed previously. So in the question, it will always be given. So you have to prune infrequent item set less than the minimum support 2 that we have assumed here, or we have been given, by checking the occurrence of the item set in the transaction database. So you have to generate the candidate of one item set first. Okay, so what is the candidate of one item set? So one item, meaning that from all of this divided them into one. So you have here item A, item B, item C, item D, and item E. What about support? Support meaning that you are going to calculate the frequency of each of these item over all item here. Okay, so you have here 1 and 2, right? So in here you have 2. Okay, what about B? Okay, B meaning that you have 3. 1, 2, 3. And C here you have 1, 2, 3. Okay, 3 the frequent. Okay, and then D 1. Okay, only 1, right? And E 1, 2, and 3. 3 here. So from there, you will merge, or you will check it with the minimum support that you have been given. So you are going to discard D here, because D is just 1. Then only you are going to generate the what we call the self-joining here. After that, you are going to generate another set of item set, meaning that after this is the one item set subset that are A, B, C, and E. D have been discarded. So next we are going to generate the candidate of two item set. Okay, for two item set, we are going to merge one item set with another item set. So for example, we are going to do a subset of A and B, and then A and C, and then A and E, B and C, B and E, and also C and E here. Okay, so these are the item set, the candidates. So this candidate has been generated as C2 for two item set. So we are going to do the second scan, where we are going to calculate the support here, right? So in the support, okay, we are going to take a look at the database back. So A and B, see, A and B that has been occurred together, only one here. So you have 1 as a support. And then A and C, how many? 1 and 2. 1 and 2. What about A and E? A, E, where is it? Okay, this one, only 1. B and C is 2. B and E is 3. And C and E is 2. This one and this one. Okay, so you have 2. So now you have to discard or do the pruning, where you are going to take a look at the support minimum support that is 2. So you have to remove AB and AE here. So from there, you are going to generate the what they call this as self-joining of the set. Okay, so this is L2 of two item set that is being left. Okay, then you are going to generate the 3 item set candidate generation, where from here, okay, from the second one here, from the L2 here, you are going to generate another candidate generation of 3 item set, that is A, B, C possibly. Or you can also generate, okay, in easier way, we can generate it like this: AC with BC. Okay, AC with BC. So we are going to have ABC. Okay, And then AC and CE. Okay, AC and BC, you are going to generate 3 item set, right? What about AC and BE? So you are going to have AB and also ABCE here. Okay, so from here you are going to have a 4 item set. This will not be generated because we are going to calculate on only 3 item set. Then take a look at ACE here. AC combine it with CE, so we are going to have 3 item set, AC and E. Okay, ACE. And then from here we can also combine the BC and CE, right? So from BC and CE, or also from BE and CE, we are going to have a similar 3 item set, that is BCE here. Okay, then what about the pruning here? Pruning occur because ABC, okay, ABC is being removed here. ABC is being removed because AB, remember AB here, is not one of the subset in L2. Okay, so you have to take a look at the item set in L2 as well before you generate the 3 item set. Okay, so AB is not in here, so we cannot use ABC, right? Same goes to ACE. ACE, do we have AC here, right? But then we don't have AE. Okay, AE. Okay, so AE is not here, so we have to prune them also. What about BCE? We have a candidate of BC and we also have candidate of CE in the item set here. So we can only use 3 item set candidate that is BCE. Okay, and then what is the minimum, what is the support of BCE? So if we take a look at here, BCE occurs how many times? 2 times. Yeah. Okay, so you won't have to prune the BCE. So this will be moved forward to the candidate 3 item set as C3 here.